Okay, so I ran out of time on that, so I'm going to throw this on top of it. And this is the perfect time for all you people that want to continue to argue about inanities to just get out of here. You don't want to think? You're not willing to think? Therefore, you're not willing to learn. Therefore, you are not my target audience. Go watch Game of Thrones and be titillated by the fact that, no way, he killed his mom. Oh, that guy went and slept with his sister. We don't care what rednecks do, people. I'm here, this is here for one single solitary reason. To increase our knowledge base. Together. So, as I was trying to say, we've got a pressure vessel that produces a certain amount of pressure. I'm calling it 50,000, and this is defined down to perfect 50,000 pounds. Pound is kind of a bad unit, but we're going to use it because acceleration and weight and mass are all indistinguishable in certain conditions. We can do all this in spin centrifugal force if we want. Anyway, we're using pounds because we all pints a pound the world around. We all know that. That's how the settlers back in the day decided on the size of their musket balls. Weigh out a pound of lead and then split it up into equal parts and know fit the caliber of their shotgun. So we have to come up with universal constants, standards, gauging. This is all real. This is where the rubber meets the road. This is the difference between a bunch of daydreaming jack-offs and the people that go out there and do stuff and build this country from the ground up. I want to be one of the people that builds stuff. But more than that, I'm finally realizing as I teeter off into the dregs of my life here, whining and screaming uncontrollably, that the people that do that are shrinking. They're becoming less and less. Most people are willing to live vicariously and get their information from other people. That's just bullshit, people. Learn to think. So you got a pressure vessel. It exerts 50,000 pounds, we know what those are, per square inch, we know what inches are. And the only place on the gun that it can exert that force is on this bolt face area. I used a big bolt so that you could see it. That's the only place. The rest is all contained by solid steel. This is the only movable part. And when that force is exerted, it's transmitted to the barrel itself, which is threaded. So it's transmitted to the barrel joint. It's transmitted to the threaded lockup. This is that big bolt face, cartridge face, slams against here, pushes the barrel, tries to disrupt this. You've either got an imagination or you don't, people. And for those of you that don't, go take a flying leap somewhere, because if you can't visualize that this right here is a 50 BMG barrel, this right here is a 50 BMG bolt, and when that cartridge goes boom, 50,000 PSI, tries to go everywhere, but it can only go this way. Thus it gets translated to, it gets transmuted to, it gets applied to, it gets used on the separation of this joint right here. This bolt face is a certain number of square inches. This one happens to be getting hammered with 0.138 of full value of a square inch. 50,000 pounds per square inch multiplied by the size of this hole right here means, in the case of the 50 BMG, you get almost 7,000 pounds of pressure on this joint. Pressure, pounds. You hold the action in a vise, you hold the barrel in a pair of pliers, and you pull 7,000 pounds. 6.5 tons. That's pretty obvious that if you did that to this little bolt, 6.5 tons, it would just snap this bolt off. That's called yielding, people. When it snapped that off, all of a sudden there's no pressure. It loses its alignment. Work with me slowly here and pay attention. Separation at the barrel joint to action has nothing to do with shooting the barrel off, with loosening up the components. It has to do with stretching the barrel tenon, which is a bolt. Stretching and it resetting differently. Now, in every one of these discussions, you got some butt brain that'll come on and say, well, I took six barrels on my PPC out to the range, and I screwed them together, boom, and I went and shot a .092 group, and then I shot one in the twos, and I shot a whole bunch of groups down below .2, then I unscrewed that barrel, and I screwed another one, and I did the same thing, and anybody that's dumb enough to think that that gun ain't shooting, and I tried that line of logic because I was so proud of the first Jim Borden gun that I got, and I had a bunch of barrels for it. I started talking like that, and Jim Borden interrupted me. I don't normally hope that the people I reference carefully, watch my stuff, because Jim Borden doesn't really want to be mentioned in the same breath with me, and I understand that. But he said, Al, stop. Enough. I hope you don't make this private, that you shoot one of my guns hand tight. Well, I thought these are so good that... Please understand that the barrel joint needs to be in extreme tension not to reset. Yeah, it'll shoot okay. Yeah, it'll shoot pretty good. Yeah, it'll shoot to the point where Jim's very nice. Jim's very polite and very nice. It shoots to the point where you, at your skill level, probably can't see the difference. You could probably hand tighten the barrel, and you could probably go shoot a tight barrel, and whoa, that just wounds me deeply in my heart bone, because it is so true, and it was so true, and Jim was so right. Yet, some child who plays around with accuracy and can't recognize, this same child will come on later and ask where his flyers. How come I shoot 2-in-1 groups? How come I shoot groups that are 2 in one hole and 3 in another? I'm fighting with this. My scope, I gotta send my scope. There's so much that can go on that can just be cured with a tight barrel, people. A PPC needs 50 to 80 pounds, foot-pounds, the way it's normally set up, just to lock that joint up, just to eliminate that variable. At 1,900 pounds of force. Now you step up to a 308 with its commensurate .044 presented inches. That jumps to 2,200. Got hold a little tighter, peeps. Little tighter, okay? You get bigger fish, you got to hold on to that pole. You might take the pole right out of your hand. This is not hard. You go up to a magnum bolt face. Almost double the square inches presented. 0.061 now. You don't have to understand this if you have convinced yourself you're too stupid to understand it. Don't even use that on me. I'll spit right back in your face so hard it'll leave a scar. I don't want to talk about it. You're plenty bright enough to figure all this stuff out. But you're just, for whatever reason, some of you are not doing it. I watch these fights on the internet. I watch them devolve into childish drivel. And it just drives me around the bend, up the wall, over the edge, and deep into the depths of the sea where I drown in sorrow. Mag bolt face 3050. Nothing else has changed except the size of the bolt face. Now it's exerting 3,000 pounds on the same joint. Lapua bolt face 3,400 pounds. Everything else is the same, people. A bigger bolt face needs more tension. Now, to understand that tension is generated by screw threads. Those screw threads, again, are easily mathematically defined. the screw. I'm not even trying to use this one to show it to you because the life's short and you die. I don't need to. You either get this stuff or you don't. That screw thread is an inclined plane, a ramp, as it were, wrapped around a post. And the lubricated parts go up that ramp. This is no different, people. No different than rolling a keg into the back of your freaking Dodge Ram. Some people can lift a keg up into the back of their pickup truck. Some people need to lay up a plank and use it for a ramp and roll the same barrel up into the pickup truck. Some people have to get a longer plank and make the ramp less steep, and it takes less force to roll it up. In all cases, you're moving the beer keg from the ground into the back of the pickup truck. Same work. There's so many ways I could go with this to talk about how gearing doesn't change anything. The chip in your fur doesn't change anything, you dumbass. A power stroke makes X horsepower. How you translate it, where you spread it, you burn some fuel, it makes some power. You can go up, you can go down, you can go slower, you can go faster, you can muss with the stoke, you can muss with the flow, you can muss with all kinds of things. But in the end, it's just changing the steepness of the ramp. If you don't know that, then please don't go out in front of God and everybody on the inner tube and proclaim your ignorance to the world, because you're just wasting our most precious thing. That finite thing called time. We got all kinds of retards arguing all the time about sustainable fuels and reclaimable fuels and recyclable fuels and all these supposedly corn is somehow more. No. If you're too stupid to understand that gasoline is solar power, it's renewable solar power, then don't argue about it on the inner tube because you're a boob, you're a rube, you've been duped. This is the same thing. Now, as the joints get bigger, the tenons get bigger, the bolt faces get bigger, so that the applied forces are applied to a bigger area, that moves those curves around a little bit. Your little Savage 20 TPI joint has got a very long, low ramp. You need a 20-foot 4x8 to roll your keg up into the back of your pickup. And you need a low pickup. And that is a Savage ramp. That's a Savage thread. That's a 20 TPI thread. Grandma could hobble out there and roll that kegger up into the back of your Mazda. Big Ralph can walk up to it and grab it between two hands and lift it into your Mazda. Grandma ain't got quite the strength in him does. So she has to roll it up a long ramp. Therefore, a Savage. The whole thing is designed by engineers. These are people who apply numbers to things. And they said, okay, we've got a system. What requires a barrel to lock up, that requires a certain amount of force. Got to get those two surfaces hammered toward each other with a certain amount of force. If we do that with a 16 TPI, it's going to burst the restraining nut. That flimsy little piece of crap nut Savage puts on there. They had to go to 20 threads per inch to even make it work. But 20 threads per inch at 60 pounds, foot-pounds, will tighten that joint together. You gotta understand, people, this joint, you've got to visualize this joint. At some point, you have to realize that this joint, I could drop many different ways, is trying to separate. That's the barrel. This is the action. This is the barrel. Use your powers of imagination. The little savage action nut that's very fragile, very small. Build the same thing in a 16 TPI and try to tighten it up enough to get these two surfaces to clamp together, and it'll bust the nut. So you drop that ramp, you drop the thread count, you bring it down to where 20 TPI, same force on the wrench, will tighten these pieces together, and it's harder to tear them apart. But in the end, it's trying to tear that apart. And you're trying to counter it with the threads on the screw joints. And they range from 20 TPI on the Savage end, which is down where the cheap guns dwell, up to the high-end guns, and some of them that have got large bolt faces exert a lot of actual pressure because of this. This goes back to that blown-up servo thing. The design is flawed. It relies on this cartridge remaining intact so that the only force is exerted on the system right here. You cut a hole in that cartridge and let the gas out, and it starts impinging on the whole inside of the system blows up because it must, because this little surface gets increased to the whole inside. But enough on the Subaru. That's going to play out however it's going to play out. But the fact is, the simple fact is, it's a retarded design. Now, in a normal design, if the case ruptures, this bolt face pressure actually drops. It plummets to zero because the gas can bleed off. But let's stick with intact cases. This big old 50 BMG has got that huge thing. 0.138. That's 1/8 of a square inch. So you take your 50,000 pounds and you apply it to 0.138 of an inch, and you get, see if I can get this in focus, almost 7,000 pounds of actual force. Actual force working to open this joint up and reset the barrel. Not to shoot it loose now, people. It's not going to shoot loose and go spinning off across the cornfield. It's going to, in fact, shoot tighter every time you pull the trigger. But any disruption of that joint, any movement of that joint, creates problems which cause inaccuracy. I don't care that I used to believe that I could hand tighten the barrel and win a tournament. I didn't know what I was talking about. I've rectified it and correctified it many, many times. And Jim Borden was very nice to me in the first correction, saying, please don't take one of my guns and go to a competition and start bragging about how well it shoots hand tight. Because he's an actual. This is the difference, people. He's an engineer with a big E. He's an engineer who understands what engineer is. I went to gunsmithing school, and up here on the wall above me, I've got gunsmithing kinks, and every one of them's got a little cartoon in there about, I used to read about gunsmiths, and now I are one, or something to that effect. And that's funny. Well, I guess it's funny if you're 11, and if your mind's in a certain place. I'm not interested in opinions. This channel is not set up for opinions. This channel is set up so that together we can go explore why things work and why things do not work. And I'm here to tell you that accuracy, consistent day-to-day accuracy across and around and through temperature changes and whatever, has a lot to do with affixing the barrel portion to the action portion and locking that joint together so that no force can open it up so that it can come back and reset in a different place. Once that's stuck in your skull bone, and once you realize that all the force exerted on that joint is exerted by the explosion and the interaction of the bolt face and the end of the barrel, trying to pull that joint apart, blow that joint apart, push that. See, this is why application of force is so hard. In actuality, there's no such thing as a deceleration. Deceleration is an acceleration. It's just an acceleration applied in a different direction. That's why I have to balk a little bit when I'm talking about pounds versus mass versus, you know, one is slugs, one is mass, one is an acceleration, one is the actual mass regardless of acceleration. One of them requires gravity, but all this stuff doesn't matter. What we're talking about is we're going to use pounds to describe the force which rips apart, opens up, disassociates the joint. This hand is going to be the action, this hand is going to be the barrel, and this right here is where the pressure is exerted to tear this and move it. And it does happen. There's lots of scopes sent back because some puss brain thinks the scope is bad because the interface is slipping between his base and the top of his action. And I can't count the number of arguments that I see where people grunt and whine and badmouth people that are bigger than them. Talk about 30 years I've been shooting now with all nothing and I never shot a barrel off yet. Never shot a barrel off yet. They all shoot the same. Well, you don't know what you're talking about. You don't build winning guns. You're not capable of understanding. The worst thing is a lot of these guys are shooters. I'm not bad-mouthing Tony Boyer. Tony Boyer is a very informed shooter. But there are things that Tony's never done. By the same token, Harold Vaughn is a very informed engineer. And there are things he's never done. So, we've got to learn to get our information from the people that are pertinent to, in the same way that the law says, let the punishment fit the crime, let the expert fit the field of expertise that we're talking about. And don't drag a bunch of irrelevancies into the question of barrel torque, people. Barrel torque is important for one reason, to keep your barrel from moving. I hope this helps you understand that.